So in this video, I'll be explaining how to close their system, how we code it in Colaboratory. So this stuff is where we're importing all stuff we need to use. So pip install and .map are going to help for calculations and showing what we're doing, because pip brings a whole different set of equations that we need. So is VCS. Importing that is important because it's going to help us solve some equations that we usually would not be able to solve. And tools.trust, that gives us some chemical properties that we're going to need. So I already defined R equals 8.314. Since that's a constant, it doesn't change under any circumstance unless you're doing in atmospheres instead of pascals. It's 0.0814 or 0.0804. I can't exactly remember. So now we need to bring in the properties of some different elements here. So chem.props, oxygen, nitrogen, argon, and let's see, water. Do that. Error. Let's see. Yeah, I forgot to add brackets here. So let's see, because another error. And another error is I forgot to define this as a function, which is kind of sad, but let's see. Another error I found was I forgot to capitalize oxygen. I'm going to get that. We get what we want, and now we define the vapor pressure. So P equals P VAP 373.5, which is the boiling point of water. So, capital. Made another mistake of P I capitalized the TP, so P dot P VAP, and lowercase v. And it gives us an array of the pressures of oxygen, nitrogen, argon, water. These might not all be exactly correct, since it might go past the critical point on whatever PV diagram it is. But the more important part is water, which is pretty much gives us pressure of water of 101,325 pascals. So the next thing we want to do is a dot map. So for the dot map, we set equal to a variable. Come on. So equals dot map. And then after this, we define all the things we need farther on. So C dot, let's say, what were our initials? So C dot T I equal to 298, which is in Kelvin. C dot T pressure initial equals 100,000 for 2.93. Then we get C dot P F, let's change that to I, shorter, equals 200,000, 85.86, and these are both in pascals. And we're in pascals. Then we got volume of in vapor. So desired vapor equals 0.3 moles. Desired vapor in the water phase. So we'll just do that. And then C dot water total equals 1 kilogram. So then we need to get the initial volume of water. So C case, and you need a C in front of you. C dot VW initial equals, let's see, C dot W total divided by P remember, so it's a function of P that we defined before as chem prop, so P dot roll C dot T I, which we have up there, and we'll put the 3 out there. Then we're trying to solve the variables. Let's put a space. C dot T F C dot T, no, not T, A dot V total. So to do that, we set them to a range. So we'll do 360, 0.01 to 600. What this does is, so the range does, parentheses gives us, we put in the X value, so we're doing 360, put it in 1.1 low and high 600. Oh, I forgot to calculate the R here. Yeah, we'll give a different function, which would be bad. And for this, I'll do range of 0.01, 1. And then I realized this doesn't make any sense because, so let's delete that. So you get a range of 0.01, so that's what's going 0 to 0.1. We got, so now that we got this, we can define our model. So let's go a shift enter here. Let's say shift enter. Control C, Control V, Control Z again. Delete this. So then you do you define your model. So define model C R, and this is where R stores intermediate values that we're going to be using in the equations that we're going to be solving. So first we need the vapor pressure of water, so R dot VP water, so that's a new variable that I haven't defined down there, equals, let's see, P dot PVAP of C dot T F third array, third value on the list, which is why I have that. Next we find VVAP. So VVAP is V, let's do R dot VVAP is equal to, VVAP is volume total, so C dot V total minus C dot VWI. So now we need the airs of mole, or the moles of air. So my bad. So you do R dot in air equals R dot P I C dot P I, and then not capitalize the C, so C dot P I times V R dot V Vap divided by, let's see, R times T I plus C. So then let me check and run this, see if it works. And it's saying, forgot. On. So, okay, we calculate the pressure. So R dot P equals moles in air times R times C dot TF divided by V dot C dot V R dot V F plus VP of water. We need to add an R2 to make it correct. And to see if we're right, we can do like another one, which is R dot V W N equals, let's see, the vapor, so equals R dot VP water times V, so times R dot V Vap divided by C dot TF times the constant R. So let's do that. We need to make our constraints. So P constraints R dot P and C dot P F. So that's 1. Then we need a constraint for water. So water dot in constraints. And then we got R dot V underscore W underscore N. And then we got the one down here. So it's C dot V underscore W underscore desired. And then we need to return these constraints. So return P constraints W in constraints over, so they're under the model.